Hello everyone, this is Adnan and welcome to Chemistry with Adnan. In this lesson, we will be covering, first topic of chapter 3 with 3.1. Chapter 3 is stoichiometry, and this topic is 3.1 for formulae. We are covering the entire IGCSE Cambridge Chemistry 0620 syllabus, along with other GCSEs and IGCSEs exam boards such as edXL, AQA, and their lectures can be found on my channel. I also offer one-on-one tutoring lessons, but the seats are very limited. The Google form is given in the description. You can fill it out if you need one-on-one lessons. I also offer group lessons. I have a community, high school community on school.com, and the link is given in the description, where I offer a free lesson once a month, where you can ask me questions and suggest me topics that you find difficult. And I also offer group lessons on school.com high school community, which is a premium package which you can subscribe for. Okay, so let's see what do we have here in this topic. 3.1 formulae core. Topic 1, state the formulae of the elements and compounds named in the subject content. So as we study chemistry and we study uh, you know as we go through this course, so there are some molecules that we see in our syllabus. For example, calcium chloride, or sodium chloride, for example, right? So like, for example, sodium, the symbol is Na, and chlorine, the symbol is Cl, and they join together to create NaCl. This is sodium chloride. And yeah, so these are the symbols. And this is also a symbol for, this is a symbol for chlorine. And that's the formula of the product that they make, or the compound that they make, right? These are not, if I have to write a balanced chemical equation or a chemical equation, I will be using Cl2, but that is for the upcoming topics. Okay, so and again, like hydrochloric acid, you should know that the formula is HCl, hydrochloric acid, right? And oxygen molecule, we write it like this. Nitrogen, it's N2. These are diatomic molecules, so we write these like this. So the next topic is define the molecular formula for a compound as the number and type of different atoms in one molecule. So how do you define a molecular formula? So molecular formula contains actual number of atoms. So like, we have two types of formulas. We have empirical formula and molecular formula, although empirical formula is not included for the core students. But I have to explain it here so that you can understand molecular formula in a better way. So let me write glucose. So the formula for glucose is C6H12O6. So and if I write its simplest form, the simplest ratio of these atoms, so that is going to be CH2O. I divide this whole thing by 6, and I get a simplified version, CH2O. So that is the empirical formula. So what is empirical formula? Empirical formula contains the simplest ratio of atoms in a molecule, and this is going to be the molecular formula. And in a molecular formula, we have actual number of atoms. So in glucose, we have 6 carbon atoms, we have 12 hydrogen atoms, and we have 6 oxygen atoms. And if the question asks you that how many elements, how many atoms are there, in total. So you just add these numbers. So this is going to be 24. So in glucose molecule, we have 24 atoms. And how many elements are involved? So carbon, hydrogen, and oxygen, 3. Okay, so now we take a look at the third topic, which is deduce the formula of a simple compound from the relative numbers of atoms present in a model or a diagram. So this is very interesting. So let me draw this diagram for you. Let's say this is carbon in the center, and these are the hydrogens that are connected on the sides with this central carbon atom. Okay, so now if the question asks us that what will be the the formula, so you can see that C, one carbon atom and 4 hydrogen atoms, so this will be CH4. Similarly, if I draw another model or another diagram like this. Okay, so what will be the formula of this compound? So this will be C2, 2 carbon atoms, and 1, 2, 3, 4, 5, 6, H6, 6 hydrogen atoms. This is known as ethane, which you don't have to worry about now, but this will be included in organic chemistry, which is, I guess, topic number 11 or 12. Anyways, so now if someone asks you that how many atoms are there in this molecule, so you add the total number of atoms. 6 plus 2, we have 8 atoms. And how many elements are involved? So 2. We have 2 elements. We have carbon and hydrogen, right? So you must be able to distinguish, you must be able to read the question accurately. I have included some practice questions from the past papers. At the end of this lesson, we will be discussing those. But here I also, I must explain this, that if the question asks you about the number of atoms, so you just add all the atoms, you just have to count each and every atom that is present on the molecule. And if the question asks you about the elements, the total number of elements, then you will not say that 8 elements are involved. No, elements, you must have to distinguish that if you have 2 different elements, just write 2, right? So this is very, very important to understand. So now topic number 4, subtopic 4, 3.1, for formulae. Subtopic 4 is construct word equations and symbol equations to show how reactants form products, including state symbols. So let us talk about the state symbols first. So state symbols, we have, for S for solid. So let's say if any reactant or product that exists as a solid at room temperature, so we will write S in parentheses at the bottom right. I will write the equation for you, so then you will understand. So for now, so L is for liquid. This is another state symbol, which represents that what will be the state of that reactant or the product that is being produced in a chemical reaction. And then we can have G for lowercase g for gases, and AQ if something is dissolved in water. So this is aqueous, right? Okay, so these are the state symbols that we usually use in chemical equations. So now, what is an equation? Like construct word equation. So word equation means when the names of the elements or compounds are given, word equation. So in word equation, we do not use any chemical formulae, right? So this is important for you to understand. So if the question says write a word equation, so you must write a word equation. If the question says that you write, uh, you know, you write a symbol equation, then you write a symbol equation, right? So now let me give you an example here. So let's say sodium reacts with chlorine to produce sodium chloride. Write the word equation. Okay, so for the word equation for this reaction will be, you just write sodium, and this is one reactant, and then you write a plus symbol, which is distinguishing it from the other reactant. The other reactant is chlorine, so I'm going to write chlorine, and then we use arrow, which represents the direction of a chemical reaction, or which we read as to produce. So sodium chloride, so you must not write NaCl, you must write sodium chloride. So these questions are very simple when they appear on the exam. The answer is hidden in the question. I mean, you just have to correctly identify that which ones are the reactants and which one is a product, and you should know that reactants must be separated with a positive sign, and for the direction to produce, we must draw this arrow, and if there is one product, you just write it like this, and if you have more than one products, then again a positive sign will be used and another product will be written. So very simple. Okay, let me see what else. Okay, yeah, so let me just read it again. Construct word equations and symbol equations. Okay, so now let us use the symbol equation. Let us convert this into a symbol equation. So periodic table is given more at the end of the question paper, so you don't have to memorize, but you should know how to write a chemical equation using symbols. So sodium, it's a metal, so it exists independently, so it will be just Na, and it will be a solid. Metals, they exist in a solid state at room temperature, except for mercury, and then you will again add a positive sign. So chlorine, we have talked about this in our previous lessons in chemical bonding in the previous chapter 2, that these are diatomic molecules. So these gases, nitrogen, oxygen, chlorine, right, fluorine, they all exist as diatomic molecules, and they are like covalently bonded to each other. So since chlorine is not a metal, so we cannot write just Cl, it must be Cl2. Okay, and again the state, so we know that chlorine is a gas, so we will write G. As I've mentioned earlier, that the state symbols are written at the bottom right of the symbol, and then the arrow, and then sodium chloride, it is going to be NaCl, right? And to balance this equation now, we can balance it. You can see that you have two chlorines on the left, there's only one chlorine on the right, so you put 2 here. So this makes chlorine changes chlorines from 1 to 2, but it also changes sodium. Now we have 2 sodiums on the right and 1 on the left, so I put 2 here as well. So now this equation is balanced, right? I have another video on balancing chemical equations where we use trial and error methods. We analyze the equation and we balance it. But again, here I would like to say that balancing chemical equations is just a matter of practice. If you know the basics, if you know the rules, that where you can change the numbers and where you cannot change the numbers, so then it's just a matter of practice. The more you will practice, the more you will get better, and a point will come where you will look at the equation and your mind will intuitively throw numbers at you. You will not even have to think. You just look at the chemical equation once, and automatically your brain will start throwing numbers at you, and you will know where to place them, and the equation will be balanced. But initially you will have to struggle, and the method is called trial and error method. So yeah, I think that is all for this topic. Aqueous, this will be like, for example, for aqueous, let me write aqueous equation. I think we can practice another equation. So let's say the question says that, we have a hydrochloric acid reacting with sodium hydroxide. So the formula for hydrochloric acid is HCl, which is found in aqueous state. In a liquid state, it is dissolved in water. Like pure HCl is a gas, we dissolve it in water and we get a very strong acid. So since it is dissolved in water, we write aqueous, that it is dissolved in water. And sodium hydroxide, the formula is NaOH, and this is also aqueous. This is a strong alkali, this is a strong base, and they react together to produce sodium chloride. Now salt, it is ionic compound, it is soluble in water, so it will also be AQ, and water is produced as a byproduct. So why now the question arises that why I am writing solid here for sodium chloride and aqueous for this sodium chloride. So the reason is that we are reacting together reactants that already contain water. So when this product will be produced, this will be dissolved in that water, right? And water is also being produced as a byproduct, which will further dissolve this. But here, we don't have any involvement of aqueous reactants, and there's no water being produced as a product. So that is why this sodium chloride will be produced as a solid state. So okay, so now we move on to the extended topics, which is the first one is define the empirical formula of a compound, which I already explained. It gives us the simplest ratio of atoms as the simplest whole number ratio of different atoms or ions in a compound. So again, C6H12O6, that is a molecular formula, and empirical formula will be CH2O, that is the simplest ratio. So I think that is all here. I don't think we have to talk about this in more detail. Okay, so for practicing, what will be the empirical formula for this molecule with the molecular formula C2H6? So write in the comments below the empirical formula. Convert this into empirical formula. What will be the empirical formula for C2H6? Okay, so now we move on to the next subtopic, which is deduce the formula of an ionic compound from the relative numbers of the ions present in a model or a diagrammatic representation, or from the charges on the ions. Okay, so this is very interesting. We have talked about it in our previous lesson, but let's talk about it here again. So deduce the formula. So for ionic compounds, so ionic compounds, they have cations, and they have anions, right? And we already know that ionic compounds are neutral. They are electrically neutral. What does it mean to be neutral? It means that the charges, the positive and negative charges, they balance each other, right? So this is the main concept behind writing the ionic formulas for the ionic compounds. Excuse me. So how do we write formula? Let's say, okay, what you need to know, this is a revision, we have already covered this, but since this topic demands, so I must repeat it again. So let's say this is group 1 and this is group 2, and these are transition metals which we completely ignore at the moment here. And now this is group 3, right? And group 4, that's group 5, this is group 6, and group 7 and group 8. So these are again some elements from period 6 and 7, which we don't have to do anything with them yet. Okay, so this is how roughly a periodic table looks like. So remember that group 1, 2, and 3, they contain metals, right? And metals, group 1, 2, and 3, and non-metals, and these are group 4, all the way, group 7. I'm excluding group 8 because they do not take part in chemical bonding, because their outer shell is complete. So we don't have like compounds for group 8. We have a few exceptions, but obviously we will not be talking about that here. Okay, so uh, let's say we have an element from in group 1, which is sodium. Let's say like we usually, like we have lithium here, but this is not for reference. I'm just giving you examples. Okay, so lithium, let's say it wants to make a bond with a non-metal. So wait, group 4, group 5, group 6, this is group 7. Okay, so let's say lithium wants to make a bond with oxygen in group 6. So what will be the formula? Very simple. Step 1, write the charges. Write the charges on elements, right? So how will you figure out what will be the charge on a certain element? The charge is related to, for metals, it is related to the group number. So lithium is in group 1, and metals, they lose electrons, so they will make positive ions. Metals will make cations, and non-metals, they gain electrons and they make anions. Okay, so lithium, since it is in group 1, it's going to lose 1 electron and the charge will be +1. So let me just write the charges on the group. Lithium, group 1, they will make +1 ions. Group 2 elements such as calcium, magnesium, and whatever, they will make ions with +2 charge. Boron, aluminum, and these guys from group 3, they make ions with +3 charge. And carbon, they gain 4 electrons, they share. So we skip 4 for now and we go to group 5. So this will be -3, they're going to gain 3. 6, they're going to gain, group 6, they're going to gain 2. And group 7, they're going to gain 1, so -1. Yeah, okay, so yeah, and oxygen is in group 6 here, so this is group 6. Okay, so for oxygen, the charge will be -2, right? So how do I know that charge is -2? It belongs to group 6, and oxygen has 6 electrons in its outer shell, and it needs 2 more to have a complete outer shell. So that's why it will gain 2. So that's why the charge will be -2. Okay, now this is step 1. Write the charges on elements. Very simple. Again, this is a revision. I've already explained these things in the previous chapter. So if you haven't watched that video, I would suggest that you watch that video and come back and watch this. So this is going to be now step 2, apply crisscross method. So we apply this little trick, which is called crisscross. And how does it work? You drop the charges will disappear, and this 2, it will come here at the bottom right of lithium, so Li2. And since there is only 1 charge +1 on lithium, so we don't write anything when it's 1 on the bottom right side of oxygen. So this will be the formula, Li2O, and it makes sense because I mentioned earlier that for the compounds, the charges must be balanced, right? So you can see that in order to balance 2 negative on oxygen, you must combine 2 lithium atoms, each with +1 charge. So you see, this will make +2, and oxygen has -2, so +2 -2 equals to 0. So this ion, this compound is electrically neutral, right? So again, let's say if sodium wants to combine with nitrogen from group 5, so what will be the formula? Again, step 1, write the charges on the elements. So on sodium is +1, and nitrogen is -3, because 3-, because nitrogen will gain 3 electrons to have a complete outer shell. So now apply crisscross method. So this will be Na3n, right? So you will need 3 sodium atoms with 1 + 1 charge each to neutralize the -3 on this one nitrogen ion. So this now let's say aluminum from group 3 wants to make a bond with oxygen. So again, aluminum is +3 because it is from group 3. It's a metal, it's going to lose electrons. It would lose 3 electrons, and oxygen -2. So now you apply crisscross method. So this 2 will come here, this 3 will go here, and the formula will be Al₂O₃, right? So, and it makes sense again. I mean, if you do the math, so, you know, uh, uh, 3 oxygens are required to neutralize the charge on aluminum, right? So we have 2 aluminums, so the total charge is +6. So there's a -2 on 1 oxygen, so times 3 we get -6. So 2 aluminums with like +3 times 2, this is +6, and -2 times 3, -6. So +6 minus 6 equals to 0. We get a neutral ionic compound. And another thing that I need to mention here is that when the charges are the same on both metal and non-metal, for example, aluminum wants to make a bond with nitrogen. So aluminum is +3, and nitrogen is 3 negative. So we will write the formula with the simplest ratio. The formula will not be Al3N3, but the formula will be AlN, right? This is aluminum nitride. And similarly for magnesium from group 2 and oxygen from group 6, magnesium is +2, 2+, and oxygen is 2-. So the formula will be MgO. So again, I'll repeat that if the charges are the same, so we drop the numbers and we just combine these atoms with 1:1. Okay, so this was topic 6. I hope I've explained it well. And now we move on to the next one, subtopic 7, which states that construct symbol equations with state symbols including ionic equations. So I already talked about symbol equations with state symbols in the previous topic in this lesson. But let us do a few examples again, and then we will be mainly focusing on ionic equations. That what are ionic equations? Okay, so for ionic equations, okay, let's do the symbol equation, right? Again, so we have we have reactants on the left side, and if there are more than one, they are separated by a positive sign, and then the arrow, which gives us the direction of the reaction, and then you have a product. And if you have more than one products, you use a positive sign to separate them, right? So, and you must pay attention to the diatomic molecules, right? So we have H2, N2, O2, F2, chlorine Cl2, bromine Br2, and iodine I2. So these are all the diatomic molecules. So if their names appear, so you must write these formulas. If the equation says hydrogen reacts, so you will not write H, but you will write H2, right? Remember that. If the statement says that oxygen reacts with fluorine, for example, so it will be O2 and F2 reacting with each other instead of O and F. So and this will be incorrect. Okay, so now I think we understand this at this point, and also you should know what the state of a substance is. And for that we have solubility rules, which we will be covering in detail in our chapter acids, bases, and salts. So then you figure out that whether the substance will be aqueous or not. But let us write the ionic equations. So let me write this equation. HCl, hydrochloric acid, reacting with sodium hydroxide. This is an acid-base reaction, and it is producing NaCl, sodium chloride. This is the same equation that I wrote, for the previous topic in this lesson, and H2O. Okay, so water is going to be in a liquid state. It is a pure liquid, and sodium chloride will be dissolved in this water. This is also water dissolved in water, sodium hydroxide. It is a white crystalline substance which we dissolve it in water and use to, when we make it react with others, so we dissolve it. And this is also aqueous. This HCl gas is dissolved in water and we get HCl, aqueous, right? Let me see, what did I write for this, the for symbol for water? Yeah, L. Okay, this is also a pure liquid. Okay, so coming back to the topic. Okay, now, so how do you write an ionic equation? Remember that, split the reactants, and products into ions, and then we cancel out the ions that appear on both sides of the arrow, right? So cancel similar, and cancel similar ions, right? Similar, by similar I mean similar ions that appear on left and right side. Okay, so let me just write it here. Now you see this is aqueous, so when I split this will be H plus, and aqueous, so plus will be written at the top right, and aqueous plus Cl minus aqueous, right? And sodium hydroxide, this will be Na plus aqueous, and OH minus aqueous. And now the other one, this will be, again, this is aqueous, so you split this, Na plus AQ, and it will be Cl minus AQ. And remember that water, it will not it cannot split, so it will be the same as H2O. And reactants or products with a solid state, they can also, you cannot split these into positive, negative and positive ions. Only reactants and products only with in an aqueous state can be split like this. Remember that. So now let us cancel the ions that are appearing on both sides. So sodium and sodium gets cancelled out, and chlorine and chlorine will get cancelled out. So now then this is the net ionic equation. Net ionic equation will be now what is left on both sides, you just write it again. So H plus aqueous, don't forget to write the state symbols, AQ plus OH minus AQ, and this is producing H2O. Okay, so remember, for your net ionic equation, mostly you will have ions on the left and you will have a whole compound on the right. In some exceptions, you can have other products as well, and like gases and stuff, or solid, but this is how usually it looks like. Okay, now we move on to the final topic, which says deduce the symbol equation with state symbols for a chemical reaction given relevant information. So again, they are repeating these topics again and again. I don't know why, but so let's say if the question says that, or construct a symbol equation, with state symbols. I have included questions from the past papers which will cover all these topics, but and that will be a test. We will apply this knowledge, what we are learning here right now in this lesson, on these questions which I have included at the end. So you will understand that how you will apply this knowledge on the exam, or how will you use it to answer questions. So construct a symbol equation with state symbols for the following reaction, right? Okay, so the reaction is, the word equation is given, you will have to convert it into a symbol equation. So magnesium plus oxygen, and this reacts to produce magnesium oxide. Okay, so how do we write a symbol equation for this? So magnesium, it's a metal, so it will be on its own, Mg, and metals are solid. So you write S in parentheses, then plus, then oxygen. Remember that I mentioned that these are the, diatomic molecules, and they exist like this. So you should never write just O, this will be incorrect. So O2, and then write a symbol, which oxygen as a gas, which we are breathing right now from the atmosphere. And now the product will be magnesium oxide, right? MgO. So how do I know that the product will be magnesium oxide, MgO, and not MgO2 or Mg2O? This is exactly what we learned in our previous topic, that how do you write a formula between of an ionic compound. So magnesium, since it is in group 2, so it will have a 2+ charge, and oxygen, since it is in group 6, so it will have a 2 negative charge. So that is why you see, since the charges are the same, so MgO will be the formula. And magnesium oxide, since there's no aqueous on the reactants and there is no water as a product, so magnesium oxide, it will be solid, right? And yeah, so this is how, and it has a very high melting point. It is an ionic compound with a giant crystal lattice, giant ionic structure. Yeah, so I guess that's it. So this is how you balance. Okay, now to balance this equation, again, we have 2 oxygens on the left and 1 and on the right. So I put 2 here, which will balance this oxygen, which will make it 2. Remember that you cannot change these numbers, uh, change these numbers, or add anything here at the bottom right. You can only change numbers or add numbers on the left side of the molecules here, right? These numbers can be changed or added, but you cannot change or add anything at the bottom right side of the symbols, or the compound as a whole. Okay, so as I said, I have a separate video for balancing equations. So if you are not good in balancing equations, so you should check it out. Okay, so here now after adding 2, now it is messing with magnesium. So before adding 2, magnesiums were balanced, but now they are not. So now we have to put 2 here to balance magnesium. So we have now 2 magnesiums on the left hand side, and we have 2 magnesium atoms on the right hand side, and we have 2 oxygen atoms on the left side, and we have 2 on the right side, and yep, the equation is balanced, right? Okay, so now time to solve some questions. These are very important questions. Like I was able to find some really good questions. So the first one is, it says that a list of symbols and formulae is shown, and answer the following questions about these symbols and formulae. Each symbol or formula may be used once, more than once, or not at all. State which symbol or formula represents a molecule containing only 5 atoms. So this is a very tricky question. You may think that, okay, this will be the answer because 1 sulfur and 4 oxygens, but no, this question is talking about a molecule, right? And that's an ion. So this cannot be the answer, right? So that's an ion. and we have to write a molecule, a neutral molecule containing only 5 atoms. So no, 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 3, no, yeah, 4, 5, 6, no, yes, this one, CH4. So 1 carbon atom and 4 hydrogen atoms make it 5 atoms. And this is exactly what we practiced here, if you remember, at the start of the lesson. Here, you see, in subtopic 3, I explained that when to write the total number of atoms and when to write the about the elements. So this is exactly, this is how you apply this knowledge here. Okay, so now the next question is A2A figure 7.1 shows the displayed formula of compound S. Okay, blah, blah, blah. On figure 7.1, draw a circle around the carboxylic acid functional group. Deduce the molecular formula of compound S. Okay, so again, molecular formula. What is a molecular formula? Molecular formula is, it tells us about the exact number of atoms in a molecule, right? So you just count the number, the types of atoms. So you have carbon, you have oxygen, and you have hydrogen present in this molecule, right? So carbons, how many carbons will there be? We have 1, 2, 3, 3 carbon atoms, so write 3. And now we have how many uh, uh, hydrogens? So 1, 2, 3, 4, 5, 6. So 6 hydrogens, and oxygens 1, 2, 3. So we have 3 oxygens. So remember that whenever we have a compound that contains carbon, hydrogen, and oxygen, so instead of writing it like this COH, we mostly write it as CHO, the molecular formula, right? So it's going to be carbon with with 3, and hydrogens with 6 atoms, and oxygen with 3 atoms. Yeah. So this simple calculation, the simple counting, is going to give you 1 mark, right? Okay, so now this equation, balance this equation. So how to balance this equation? Okay, so we have 6 cobalts on the right hand side. You see, this number gets multiplied by this, so 3 times 2, 6, and here we have only 1. So since there is already 2 here, so I cannot change it, so I must write 6 here to balance cobalt, and the rest will be adjusted. So okay, so now I have to change the number of atoms here as well. Balance this equation. Okay, yeah, 6 oxygens and 2 oxygens here. So we have 6 cobalts, and we have 12, 8 oxygens, right? So we have 8 oxygens. How? This 6 times 1 oxygen, 6, and then this plus 2, right? We have this is counted as 2 oxygen atoms. So 6 plus 2, 8. And similarly, this is 4, and 4 times 2. This number gets multiplied by this as well. And this will be, oxygens are 8 on the right-hand side. And 3 times 2, we have 6 cobalts on the right-hand side. Yep. So the equation is balanced. And now we move on to the next one. Question number 4, complete the chemical equation for this reaction. So here, we can see that you have 4 hydrogens on the right side. So you just write 2 here to make 4 hydrogens here as well, right? And now we need to balance the oxygen atoms. So 2 and 2, 4. Yeah. So 4 oxygens are there on the right hand side, right? So 2 times 2, 4, and 5, 6, 6. So I will write 3. So 3 times 2. So yeah, so you see, now the equation is balanced. So let's analyze this. We have 4 hydrogens on the left, 2 sulfurs on the left, and we have 6 oxygen atoms on the left. Right? So 2 times 2, 4, and that's 2 times 1 sulfur, so it's 2. And on the right hand side, we have 2 times 2, 4, so we have 4 hydrogens. So 2 times 1, 2, we have 2 oxygens here, and 2 times 2, 4, so 4 plus 2, 6 oxygens. and 2 sulfur atoms. Yep, that's right. So these 2 and 3, these are the correct answers. They will get you 2 marks. Next question. Okay, so okay. So yep. All right. So deduce the molecular formula of structure Q to show the number of carbon, hydrogen, and oxygen atoms. So this is Q again. So you just have to do the simple counting. So carbons 1, 2, 3, 4. So you write C4, and you now you count the hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 hydrogens, and 1, 2, 2 oxygens. So this is structure Q, and that is its uh, molecular formula, right? So this is how we you will be asked questions on this topic to 3.1 formulae. And yeah, again, like if you need one-on-one lessons, contact me. If you're preparing for November exams or May-June session, book early, because the seats are very limited. And if you wish to join my group lessons on the school community, school.com, high school chemistry, you can subscribe there as well. So all right, and this will be all from my side today. I'll see you in the next one. Take care. Bye-bye.